Marine for their technical and vocational education. Apart from regular teaching and training, he also acted as a team member for curriculum and examinations from 2015 to 2016. He started career as a lecturer in an Aurora Group of Engineering Colleges, Hyderabad in 2006 and continued for 2.5 years. After his master's, he worked as assistant professor in KKR and KSR Institute of Technology and Sciences, Guntur, Andhra Pradesh for 3.5 years. He got ratified as a lecturer by JNTH in 2007 and assistant professor by JNTK in 2012. During his working time, he performed various roles apart from regular teaching, like internal exams coordinator, department coordinator, student association coordinator, etc. He completed his PhD in electrical power systems with a focused research on electrical microgrids in December 2020. MTech from Bharat Institute of Engineering and Technology, Hyderabad in February 2011, and BTech from Dr. Samuel George Institute of Engineering and Technology in April 2006. He is a senior member in IEEE USA, associate member in IETE India, member in IAE-NG China. He is continuing his research through publications in reputed journals, national and international conferences. He holds 1 Australian patent grant and 2 Indian patent publications. He published a book chapter in Springer Lecture Notes, presented 2 guest lectures for KL deemed to be University Vijayawada. He attended 10+ short-term training programs and workshops. We are very glad for having you here, sir. The session is all yours. You can take over the session. Thank you.
Thank you so much. Am I audible? Can you continue?
Yes, sir. Yes, sir. You are audible.
Hi, everyone. Very good evening. It's nice time, actually. I'm very thankful to EEE VJIT for giving this opportunity to the management and to the department, and especially the person who contacted me is none other than Mrs. Vijayalakshmi. Thanks for conducting such type of programs, for encouraging the faculty towards the research. If any audio issue, please let me know immediately, or any screen issue, please let me know. Can I share my screen?
Yes, sir.
Can you please confirm, is it okay or not?
Yeah, your screen is visible, sir. You may continue.
Hello?
Yes, sir. Your screen is visible. You may continue.
Visible?
Yeah.
Okay. Thank you. Hi, good evening. Welcome to my session. I'm going to give small information about integration of renewables through microgrids. Since it is a 1.5 hour session, we cannot go elaborately, but for the overview, I can give you a small information. Since it is a faculty development program, I know many of the faculty members about the renewables and some of faculty members about microgrids. But don't think we are going in depth. We are going roughly the overview only, because it is only 1 hour or 1.5 hour session. So hope you will understand the concept, what it is. And first of all, I would like to say sorry, because I am feeling some throat infection. That's why I'm getting coughing. If you feel uncomfortable, please try to bear in. Thank you. Here I'm going to start my session, and thanks for the opportunity given to me once again. to all the people who are behind this program. I'm going to give this presentation in this flow. Just have the contents what I'm going to cover. Just have a look. First of all, I'm going to give introduction. Later, the renewable energy sources, microgrids, microgrids advantages and disadvantages, microgrids and power electronics, research scope, conclusion, and question and answer session. This is the flow I'm going to give presentation, and this is overall it will take 1 hour, 20 minutes like that only. So simply introduction, it will give the brief idea why I have chosen this topic and how it is related to this faculty development program. Everyone knows the renewable energy sources nowadays are very popular. Later, how these renewable sources are going to interconnect by using the microgrids. Later, some advantages and disadvantages of microgrids, because everyone knows if you take any concept that's have their own pros and cons. So we need to discuss the advantages and disadvantages. Later, the concept of power electronics. Actually, it is not mentioned in the title. Simply, I mentioned integration of renewable through microgrids. In the word integration, without power electronics, it is not possible. So, in this title, there is a hidden topic, that is power electronics. So, here we are going to use power electronics for integration of renewables in one place, which is called microgrid. Later, the research scope. Nowadays, power electronics are dominating in the industry. So, what are the gaps available? How, where we can choose the topics, and how to go research elaborately. Later, small conclusion and question answer session. First of all, don't think differently. To make it as an interactive session, I have prepared presentation slides like this, like questions and answers. So don't hesitate. If you know the answers, just type it in chat box, no problem. If you don't know, no problem. We'll discuss slowly. Have you noticed any recent climate changes from last for a few years? We are observing bad climate changes in our environment. If you see, all these are the pictures I have collected from Google. If you see all this, we are aware of this one. Especially in India, especially in Delhi, we are facing a lot of pollution. So air pollution, which is the major concept in the Delhi region and in many places in India where industries are more. And if you see the forest fire, these are happening frequently in the Amazon forest, in floods also. So if you observe these pictures, these are the climate changes happening from last few years frequently. Because of this, we are going to suffer a lot. So why these all are happening? What are all these symptoms telling to us? Only one, these are giving a danger bell. Means these are saying the pollution is going to increase day by day, so that the atmosphere changes are happening. That's why we are observing all these climate changes. So why all these are happening? If you observe the reason, ultimate reason is global warming. Due to the global warming only, all these are happening. But for the global warming, what are the causes? If you observe and analyze, I'm going to give a small information, because the major causes for this global warming only. We have many things, but I'm going to discuss major. After that, I'm going to connect this concept to our topic. The first one, rapid industrialization. Agricultural practices, transportation, deforestation, resources extraction, and last but not least, but very most important, the energy demand. If you see, these are the major causes for global warming concept. If you observe all these are all due to the more population. When the population is growing, automatically our people needs must be satisfied by supplying the electricity, by supplying the things what they need through the industrialization, by giving the agricultural practices, the food. So all these are the reasons, but we cannot avoid all these things. We have to fulfill the things with minimal impact on environment. So these are the few causes.
Sir,
which
sorry
are
to interrupt.
main.
Are you changing the
Yeah,
slide, sir? We are unable to see.
yeah. Now it is in slide number 5.
No, it is not visible.
It's not visible. Currently, in which slide?
First one only, sir.
It is in
First
first
one.
slide only.
Yes, sir.
It's changing to me. Just I will share it again.
Now it came to second one.
Second,
Yes, sir. Second slide.
I came to fifth slide actually. I'll reshare again. Just give me. Is it visible now?
Yes, sir. It is visible. Now it is in fourth slide, sir.
Fourth slide, yeah. Maybe network issue. When the internet is slow, maybe it won't run. Now it is in fifth slide or fourth slide?
Fifth slide, sir. Again, you are changing, sir. Fifth slide. Fourth
Yeah.
slide.
Okay, okay. Sorry for the inconvenience, participants. So I have informed you we are observing very bad situations around the globe. Those are recent climate changes. I have shown you in slide number 3. I think you may see the picture right now. Can you confirm, anyone?
Slide number 4, sir.
Slide number 3 right now.
Now it is in 4.
4?
Yes, sir.
Yes, sir, it's 4, sir. Slide number 4.
It is changing or not?
No, sir. Can I do it for you, sir? Otherwise,
Yeah, yeah, no problem. I think slide no presentation mode, it is not moving. Yeah, you can do, please.
yeah. You just stop sharing, sir. I will share.
Okay, okay, okay. Okay, keep it, please. Can I proceed?
Yes, sir. Yes, sir.
Okay. Sorry, my dear friends, for the inconvenience. Yeah, I have told you there are a lot of changes happening recent years. I have shown you the pictures: air pollution, tornadoes, forest fires, floods, water pollution. These are the recent changes we are observing frequently, not occasionally. Frequently, we are observing all this. For all this, the main reason is global warming. Can you go to next slide, please? Next slide, please. Yeah, the global warming. This is the main cause for all the reasons. We have to control the global warming. Otherwise, day by day, the life will become very bad. So there are few there are few reasons which are majorly cause for the global warming. Can you go for next slide? I have mentioned 6 reasons, 6 causes. One is rapid industrialization, deforestation, agricultural practices, transportation, resources extraction, and energy demand. These are the major causes for the global warming. And if you think generally, these are because of the more population. When the population is growing, we need to satisfy the population requirements by doing production through that industrialization. by doing agricultural practices for satisfying their food needs, and providing the transportation facilities to go here and there, and by providing the energy demand for satisfying their electrical requirements. So these are the major causes. If you observe here, we are one of the part in that global warming. How we are one of the main cause? See, the energy demand is one of the major cause. When you observe energy demand, it must be generated from somewhere and it must be transported to the the place where it is required. So can you go to next slide, please? Okay, the electricity is one of the major cause. Do you think we are the as a electrical engineers, whatever the electricity we are producing, because of that we are polluting the environment and we are the main cause, one of the main cause for global warming? As of a few years before, I didn't think so, because lack of knowledge. Slowly after coming exploring the knowledge, I observed that we are contributing more carbon emissions into the atmosphere, so that by, global warming is going high. If you observe, not only in our country, every country on the globe, they are having electricity production by using fossil fuels. Means they're burning coal, oil, or natural gases, so that the plants are releasing carbon emissions into the atmosphere, so that the global warming is going to increase. When the global warming is increasing day by day, we are seeing these bad situations around us. So why how we are going to avoid this pollution? Means we are producing the electricity by using fossil fuels, means we are polluting the environment, and we are one of the cause for the global warming. What is the solution for this? What we need to do? That is ultimate solution. Everyone knows that renewable energy sources. Can you go to next slide, please? Yeah. For understanding this small scenario, I have taken a small example of our country. If you observe and analyze our country, automatically you will understand every country in the globe, so that you will observe the whole market or the whole the system, how it is going. If you see the population wise, India is the second largest country in the population. To satisfy these population requirements, India needs to produce more electricity, and it has to supply to the requirement where it is required. See, if you observe our Indian electrical system, before there are 5 regional grids. Northern region is on the top of the map, southern region on the bottom of the map. On your left side is the western, right side is the northern, eastern, and after that northeastern region. These are the 5 regional grids we have in India, and these 5 regional grids are having their own boundaries. We are in southern region. In that southern region, the grid is covering 5 states. One is Andhra Pradesh, second one Karnataka, Kerala, Tamil Nadu, and Telangana. These are the 5 states are in the southern region grid, and its head office is located in Bangalore. From there, these people are going to control all these 5 states power generation and load demand. Similarly, if you see the western region, it is also having the same concept. So now if you observe our Indian population, it is huge. To satisfy these population requirements, we need to produce the electricity. But what is the fuel we are going to use for producing this electricity that is going to contribute pollution to the environment? Means till now, as of our knowledge, we know that majority of the power production is coming from thermal power generation. Next slide, please. Yeah, next, please. Yeah, if you see the all India power generation category wise, in the map, if you observe, there are 3 bubbles highlighted. One is black color, one is blue color, another one is red color. These are the 3 types of power plants. They are highlighted in the map. And if you see, the whole India have many power plants, but depends upon the area, the power plant is different. Some areas have more hydel power plants, some areas have thermal power plants, some areas very rarely nuclear power plants. So if you observe this power generation in India, majority of the power is going to produce by using thermal power plants. I will explain this one little bit in next slides. Can you go, please? This is the One India, One Nation, One Grid concept. It is completed in the year of 2013. If you have knowledge, idea about this one, no need to explain this one. We have, as I told you, 5 regional grids. These 5 regional grids are interconnected together and acting as a one grid now. And this one grid, one nation concept is completed in the year of 2013. In 1991, Eastern and Northeastern grids are interconnected. Later in 2003, Northeastern, Eastern, Western region, 3 grids are interconnected. Generally, we are calling it as synchronized. So these all are synchronized together. And now in India, we have one nation, one grid concept. So these all 5 regional grids are interconnected together and operating together. Next slide, please. Another one. Next, please. Yeah. In the whole, above 3 slides, which I skipped, I'm going to explain a little bit here. If you see the total installed power of the Indian system, Indian power sector, it is 4,04,132 megawatts. Simply, it is very huge amount. In this amount, total, see the contribution of central government, state government, and private. If you see, if you consider this 4,04,000 as 100%, in this 100% for installed power, central government is contributing only 24.5%. Later, state governments are contributing 25.97. State government, central government together approximately contributing around 50% of the power. Remaining whole power is contributed by private sector. So here we have to look for the opportunity in the private sector than the government sector, because the major power producers are in private sector. So in the whole 100%, 50% coming from government and 50% from private sector. This is the contribution from the different sectors. Later, if you consider the same 100% based on the fuel you are using, first it is coming 58.41% from thermal power stations. Remaining all coming from other power stations like solar, hydro, wind, biopower, nuclear. If you observe the figure, thermal power generation, 58.41% means out of 100, 58% coming from thermal power station. Means for producing that much of energy, we are burning huge amount of coal. When you are burning the coal, automatically the power plant is going to release carbon emissions into the atmosphere. When carbon emissions are released into the atmosphere, it is one of the major cause for global warming. When global warming is not controlled, we are seeing the bad effects. So this is the flow we need to observe. Simply with this slide, I'm going to tell you only one point. Majority of the power is generated by using thermal power stations. And these thermal power stations are using coal as a fuel. When the coal is burning, then this is going to produce the carbon emissions into the atmosphere. So because of this point, we are one of the major cause for the global warming. So what is the solution for this? Do we need to stop our requirements? If you want to watch the TV, will you stop the TV without watching? Because you are one of the reason for the person who is consuming electricity, and for satisfying your requirement, the power plants are producing that power by burning the coal. Indirectly, you, me, all together, we are the end users or causes for this global warming. We cannot stop our telephone or we cannot stop our television. We need it in operation. But how to get the power other than thermal generation? The ultimate solution is renewable energy sources. So this is the one of the major reasons for looking into the renewable energy sources. Other than this, there are many, but the primary cause is only this one. Because of the pollution, we have to look for alternate solution. This is alternate solution for our power production. Can you go for next slide, please? So the solution next. See, the change the way of power generation. Before, till 10 years before, we major power production is coming from the thermal power stations. But from last decade, we are observing that there is a drastic change in the way of power generation. That is by using the renewable energies, everyone using the solar panels, windmills to produce the electricity. Why? Because to control the global warming. So whatever the way you are choosing for producing the electricity, that must be better than the existing one. It must be simpler, flexible, economical, and less impact on the environment. This is the primary reason for looking into the alternative power generation. Next slide, please. So every country must be a part of solution, not the pollution. See here, simply not you and me. If you or me sacrifice, it will not solve. Every country must follow the certain rules and regulations to be part of solution. That's why here there is one global initiation taken place in 2015 that is called, can you go for next slide? Next slide. Yeah, global initiation. See, no. Yeah, Paris Agreement. This is the global initiation. All the countries came to one stage and they agreed for one agreement, which is controlling the global warming. See, the Paris Agreement, the name came from the agreement where it's taken place. This is the agreement done in the Paris place. That's why the name is called Paris Agreement. It is happened in 2015. This agreement signed by almost all the countries on the planet. See, agreement signed by 196 countries to control the global warming. Every 5 years, these Paris Agreement people, United Nations, they will ask the countries what they did, whether they followed certain procedures to control the global warming or not. Because this Paris Agreement has certain goals. To satisfy the goals, every country needs to take their own action within their premises. So every 5 years, the country which is participated in this agreement, they must show the progress towards the change in their electrical power generation and the reduction in pollution. So this is the agreement signed by many countries. This is the global step taken by all the countries. So simply not you and me. It is initiated by the many countries. That's why from last one decade, we are observing renewable energy power generation rapidly increasing. Not only in India, in many countries, they are producing electricity by using the solar panels, windmills, biomass with alternative fuels, which are not polluting the environment much. So this is the one basic good step taken by all the countries together with a name called as Paris Agreement. So this is one of the global initiation to control the pollution. This is one of the main reason for looking into alternative solution apart from coal. Other than for avoiding the pollution. So next step, please. This is just a small information I try to remind you. As we know, we have studied electrical engineering. In that electrical engineering power system concept, everyone knows that one. Just simply, it's like a conventional grid. If you see here, we have generating station, transmission system, substation, and distribution. Means the power is generating from far away, and it is transmitted through kilometers, hundreds or 200s like that, and it is distributed to where the location, the distribution centers. Okay. For example, if you consider a small example, next slide, I have given just for idea. We have one power plant in Vijayawada, which is called Narla Tatara Thermal Power Station. From there, if VJIT wants power, they need to transfer this power from Vijayawada to Hyderabad, means around 250 kilometers distance. During this much distance, if you observe the losses, there are huge losses in transmission system. So whatever the power feeding at generating station, same power will not reach VJIT. But coming to the billing, everyone has to pay the amount for how much energy they are receiving. But the loss, who will bear this loss? That's why the concept here I wanted to remind you is AT and C losses. Next slide, please. AT and C losses. This is the one of the major factor. Aggregate technical and commercial loss. Why we are considering this point? It is an actual measure of performance of power distribution system, as it includes both technical losses and commercial losses. If you see this factor, automatically you will choose microgrid concept, because in our system we are having more AT and C losses. Because of this, our system efficiency is less. India is facing high AT and C losses. So this is the concept I wanted to tell you with the previous slides from Narlata, Vijayawada Thermal Power Station to VJIT Power System Network. In that place, we are having around 200 to 250 kilometers distance. During that 250 kilometers, who will bear the losses? How much losses are occurring? What is happening? All these are calculated by using this aggregate technical and commercial losses formula. So this is the one of the major factor for looking to renewable energy sources. First one is pollution. Second one is AT and C losses. These are the main reasons for choosing this renewable energy sources and microgrids concept together. Next slide, please. It's a small information about grid terminology. We know that grid, an interconnected electrical network for electricity delivery from producers to consumers. It's a conventional grid, microgrid. Simply, microgrid means it's a small in size, nothing other than the conventional. If you know the conventional grid, automatically you will know the microgrid. The size is different. And the second thing is microgrid will use local available resources for producing the electricity, and that electricity is connected to the local load requirements. Then if it is having excess power, based on the type of connection, it will sell to the conventional grid, or it will keep for storage in the battery systems. So this is small information, just like just meanings for everyone. Next, smart grid means it's the advanced grid with all communication technologies. So if you observe the picture, you can understand easily in every stage. Can you make it big, please? In presentation mode.
Yes, sir.
Excuse me.
Just a
Okay, if you see the first stage in the production side, in the production stage, please compare the conventional and the smart grid. Yesterday, here it is mentioned as yesterday, and in the green color it is mentioned as future. So in the production stage, we have in yesterday's case, thermal power stations, simply fossil fuel power plants are more than the renewable energy sources. If you see the future, the smart grid, it is wind power plants, solar, and biomass all are showing. Means if you observe the production stage, the pollution coming from yesterday's power plants are more than the future power plants. Those are solar and wind. This is the first difference and the benefit we have. And the second one is the market. Previously, it is very less market. Now it is very huge interconnected market than the existing one. Means simply grid is transiting from conventional to smart grid. But in between these two, we have a small word that is called microgrid. This microgrid we can consider in between smart grid and conventional grid. Before making the smart grid, we have to check the local resources and the local load requirement and about the storage and about the operation, all the factors. After knowing all these things, put the communication technologies more and more to interconnect each and everything in a bidirectional way so that you will get the smart grid. Before in conventional grid, we have one-way communication, but in coming days, that is called microgrid. After that smart grid, we have bidirectional communications. Whatever the components we have in the power grid, every component is going to interact with other component through by the way of communication technologies. So this is the one of the advanced system we are going to see in future. You can observe the same way. One major issue is when communication is involving, there is a problem of security. This is a major issue in current days, which is having high demand in research. Cyber security. That is the concept. They are not internet. They are not giving this power system internet connection directly because of the cyber issues. Next slide, please. Excuse me. Hello. Is anybody there?
Yes, sir.
Can you change the slide, please? Yes. Yes, this is the small picture I have shown you, grid transition. We have conventional grid before, and we are moving towards the smart grid. But before going to smart grid, if you understand and observe the microgrid, automatically it is the advanced version of microgrid as called as smart grid. A majority of the components we are going to use in smart grid, they are going to use in the microgrids also. So after knowing about the microgrid completely, we can design and implement the smart grid concept, because microgrid concept is only belongs to a small area. I will explain this concept in next coming slides. Can you please go? Microgrid new technology. Is microgrid new technology? Anybody heard about this microgrid before? Can you please just in the chat box say yes or no? No problem. This is we are going to observe whether microgrid is new technology or not with a small information. And how in the microgrids are spotlighted means we have some key point to highlight on any concept or any technology. When it is going to when it is spotlighted, then why microgrids are gaining popularity? These are the few basic questions. If you understand, automatically you will understand the importance of microgrid. Can you please go? Next slide. Yeah. Origin of microgrid concept. See here, I have mentioned a small information about the origin of microgrid. From where it is started? It is started in Parallel Street Station, USA. See, the station was built by the Edison Illuminating Company under the direction of Francis Octave, hired by Thomas Edison on a site measuring 50 by 100 feet. See the measurement of the site. It is only 15 by 30 meters plant, not a big one. Nowadays, if you see the power plants, they are very big. But if you see the starting one, it is very small. In that small, he started the small grid, which is going to supply power to the 85 consumers, and their load is only lamp load. Electricity for 400 lamps. See the highlights. The first central power plant in USA. It began producing electricity on 4th September 1882. Means 1882, almost it is 140 years ago, 100 years before. The concept is very old concept. It's not a new concept. Here I would like to tell you the microgrid concept is very old concept, not a new concept, but it is not highlighted for many years. When it is highlighted, we will see in the next slide. Can you please go? Next slide, please. Yeah. Next slide, please. Yeah. See, according to Pike Research, the first modern industrial microgrid in the United States was 64 megawatt. 64 megawatt microgrid. Facility constructed in 1955 at the. But most people are not aware of this concept much older. See why it is and when it is highlighted. In the bracket at the end of the slide I have mentioned, there is a place in northeastern part of the US. In that place, because of a cyclone, somehow all the area lost the power. But some neighbors observed with some of the buildings or some of the flats, they have electricity in their flat. They don't know how they got electricity because of the cyclone, the entire place was dark. So this is the main reason for highlighting, focusing, spotlighting microgrids. Okay, so the small reason is when you get the problem means during the rainy season. Generally, we know in the Indian system, in rainy season, when we have high winds, the electrical department, they will disconnect the power supply. When they disconnect the power supply, the people who are don't have electricity and they are suffering because of this rainwater and all, they will face a lot of problems. So the people who are financially strong, they will put their own grid inside. That means inverter. When the power is shut off, automatically the inverter takes place into the action and it will give power supply to the minimum loads which are connected to that one, either light or fan or AC or television, like that. Generally in India we have power cuts, so that many houses they are using inverters. These inverters are producing electricity and these inverters are supplying electricity through the batteries to the loads when there is no power from the main supply. So same concept they applied here. That's why some people they have electricity in their flats, even other people are affected because of the cyclone. This is the main reason for spotlighting the microgrid. From there it is started its journey. Next slide, please. Why microgrids are gaining popularity? It's a simple answer: due to their modularity and flexibility. It's a simple concept. Generally, after finishing all this small information, I will tell you within a word. Next slide, please. Oh, it's changed its font size and all. Next slide, please. Yeah, generally, we need some standard definition from the standard organization. Everyone have their own information. Accordingly, they will give some definition. But if you want to take the exact definition, generally we need to prefer the standard organization definition. A small definition I have given in the general manner. It is a small scale power supply network. that is designed to provide power for small community. It's a general definition. But according to IEEE, a microgrid is a group of interconnected loads and distributed energy resources within clearly defined electrical boundaries. This is the main point we have to observe. Clearly defined electrical boundaries that acts as a single controllable entity with respect to the grid. So generally, if you look into the definition, in this definition, they have clearly mentioned that boundaries means this microgrid concept have their own boundaries. It is possible within certain area. In that area, it has to design its boundaries, means how much generation is available, how much load is available, how much storage is possible, how with what is the way of connection it is having with the conventional grid. All these things we must design. This microgrid concept is not popular in India, but in European countries it is very popular. They have implemented in many places and they are running the microgrid successfully. We are looking forward to see these microgrids more and more in India also. Next slide, please. It's a small brief information. Microgrids are fundamentally not different from wide area grids, means not different from conventional grids. It is similar to conventional grid, only the difference is size, remaining all are same. For example, smaller islands have electric grids which usually qualify as microgrids. I will explain a small example here. Everyone knows that we have Sri Lanka at the bottom of the India map. Take it as an island and consider it as it has a electrical power network that is having the grid. That grid is we can treat as a microgrid because it is a island. It is having some boundaries. Whatever the electricity produced by the electrical producers in that Sri Lanka country, they must supply within the Sri Lanka only because it is a island. If they want to connect it to some other country, they need to build a long transmission line with the understanding or support of other neighborhood countries. So for understanding a small concept, we can think the electrical grid available in Sri Lanka country as microgrid. If you see India, it is a big country. In that country, we have huge network. We can think that as a conventional grid, just for the understanding purpose, not for any other things. Okay, so if for understanding this concept, I have another slide. Please go. Next, please. Yeah. Yes, see here. A microgrid is a small grid. That's it. Remaining all, don't forget everything. This microgrid, there are different types. One is standalone microgrid. Another one is grid connected microgrid. In standalone microgrid means it is a grid which is not dependent on any other things, any other neighborhood grids. It is independent one. It is having their own power generation. It is having their own load and own energy storage system. When the electricity produced is more than the load, it is going to send to the storage. When it is less, it is going to take from the storage system to satisfy the needs in that particular area. So types of microgrids we have two. Only one, there is standalone system, and the second one is grid connected system. If you see the second one, grid connected, I have indicated in red color conventional power grid. Means it is the main power grid which is going to connect with a microgrid by using on-off switch. When the switch is on, this conventional grid is interconnecting with microgrid and it is going to give the power supply to the microgrid, because when it is having interconnection, they may connect or they may not connect. Based on the requirement, they can operate the switch. If the microgrid don't have sufficient local resources to produce the electricity, they can demand the electricity from the conventional power grid, so that conventional grid people, they will supply the surplus power to the microgrid to satisfy their needs. If microgrid have excess power and wanted to sell that power to the conventional grid, they can sell the power to the conventional grid when they have excess power. So this is the concept you can see in its second type of power grid, grid connected mode. So these are the two types microgrids. One is standalone, another one is grid connected. Again, if you go in depth, everyone have the different operating modes. Next slide, please. Yeah, standalone microgrid. See here, the standalone microgrid, I have shown a small picture. In this picture, you can see it is an island surrounded by a lot of water sea. In this island, we have one windmill and the solar systems and battery banks and all. One building, one swimming pool, some loads and some power generation. Okay. In this situation, observe carefully. When the wind is moving with high intensity, automatically wind power is going to generate. Second thing, when the date when you see the solar system, it will produce the power when sunlight is available. So solar solar system is going to produce the electricity with the help of sunlight, and windmills are going to produce the electricity when wind is flowing with high intensity. When these two are producing the electricity, that must be interconnected in one place. That place is called a microgrid. In this microgrid, this wind power plant and solar power system are going to interconnect. In this microgrid, they will analyze how much generation is coming. Later, they will check how much load they need to supply. They will compare the generation and the demand. When demand is more than the generation, they will take the power which is stored in the battery system. If it is less, the load is less than the generation, then the remaining is going to store in the battery system. Simply, if the generation is more, they will store something in the battery and supply remaining to the load. If the generation is less, they will take from the battery bank to supply the load. This is the only standalone system concept. But here there is a one question. You may think or you may wonder, what if wind is not flowing with high intensity? What if sunlight is not sunlight is not there? At that time, how these loads are going to supply? What they do, how they are going to satisfy their needs. For that reason, there is one more chance. They can use diesel generator sets. Apart from the energy storage, they can use the diesel generator sets. So finally, in this standalone microgrid, we are having windmills, solar system, energy storage system, that is battery banks, and the last one, diesel generator sets. These four must be interconnected together and analyze what is the generation and what is the load. So this small concept we can see in your own college also. In your college, you can form a microgrid when you have 3 to 4 power generation sources available. I think many of the colleges, they are implementing their solar systems. They are putting rooftop solars on their buildings, and they are getting the electricity from the solar panels, and it is connected to the lights and fans during the daytime. Means the colleges or universities or institutions, they are going to use their own power system. They are going to design their own power system by implementing the renewable energy storage, renewable energy sources, which is sun. So after this one, the colleges, as a backup, they have generators. Every college, they have backups. that is diesel generators. Colleges have generators. They have started implementing their solar systems, and some places, if you see, they are having battery banks to store the energy. That is like in server rooms, they need to supply the power continuously to the server without any interruption. That how they will supply, by using the battery systems. So in college, if you see, they have battery systems, battery banks, they have diesel generator sets, they have solar systems. If they take a small further, if they put small windmill, they may have 4 energy systems: windmill, solar system, battery banks, and diesel generator system. These 4 going to interconnected and form a microgrid, that is called standalone microgrid if it is not connected to the main power source. So this is a small example we can read. Next, please. Next, please. Grid connected type microgrid means, if you see the same example, colleges, they can form microgrid. But during some bad situations, if the weather is not good, the wind is not sufficient to rotate the windmill, and the sunlight is not good, means cloudy days, how this electrical requirements must be satisfied. They cannot run the diesel generator continuously, because the diesel price and the oil prices, petrol prices are very high. If they run continuously in one day, they need to spend a lot of money for the diesel. So for reducing this, they are going to another step, that is going to connect to the main grid. Apart from this internal grid, they are going to connect to the main grid. When they have problem within the internal grid, they will take the electricity from the main grid. If they have excess power, they will supply to the main grid, so that they will save some money, they will earn some money by using this grid connected type microgrid. Next, please. In the grid connected mode, grid connected microgrid, we have different modes of operation. The first one is off grid mode. It is just like standalone microgrid. Means we have the connection switch between the microgrid and the main power grid, that is conventional grid, but this switch is in off mode. Means the microgrid is operating alone itself. It is not taking power from the conventional grid. It is not giving power to the conventional grid. It is operating in standalone mode. So if you see in the picture, static switch and point of common coupling. Point of compound coupling is the switch connected between the microgrid and conventional grid. If point of common coupling is not in operation, then this microgrid is similar to standalone microgrid. At that time, the feeder A, whatever the feeder A having its generation and load, that must be supplied over there. Feeder B, load must be supplied over there, and feeder C similarly. But if you see the feeder D, there is no power source, there is no generation, and it is after the static switch, and it is in open condition. So the feeders A, B, C have the resources like solar power station, wind, or diesel generators. That power cannot be supplied to feeder D, because the static switch is in open condition. Only feeder A, B, C, they will produce their own energy, and they will interchange the energy between them, and they will satisfy their load requirements. So this is the off-grid mode, simply a standalone mode of operation. Next, if you see the on-grid mode, in the on-grid mode, this point of common coupling is shown in green color, that is in active mode. Means the main grid is connected to microgrid, and the power exchange will take place wherever there is a shortage. If the microgrids are in need of power, they will take the power from the microgrid, or if they have excess power, they will sell that power to the conventional grid. This all will happen by using point of common coupling. As I told you before, Without power electronics, there is no concept of microgrid. Here you can see the point of common coupling, static switches, all these are by using power electronic devices only. This is possible only with the help of power electronic components. So power electronics are going to playing a vital role in the microgrid concept. Next slide, please. Next slide, please. Next slide. Yeah. See, this is a small report. I took it from the internet to tell you how big is the microgrid market, how the companies are competing to put their components in the market. See, subcontinent key market players. I have at the bottom of the slide. You can see key market players. ABB Group, Eaton Corporation, Excel means these are the companies. They are producing their microgrid related products and they are testing, they are implementing in the market. So simply, microgrid market is not a small one. It is a very big one. I will show you the statistics in next slide. Can you please? This is the small reason to prefer microgrids to avoid the power outages and cost saving. I will tell you a small example. Next slide. Yeah, this is a small example to understand the cost saving. This is one of the shipping company. In this shipping company, they will unload the shipping containers. For loading and unloading purpose, they need to operate the machine. This machine needs the electricity. If they take the electricity continuously from the power supplier, they will get the huge bills. They need huge electricity so that they will get huge bills. Here, if they use regenerative cranes means it is having some special function. It will consume the electricity when they lift the container and generate the electricity when they lower the container. Means while it is lifting, it is taking the electricity. When it is dropping, it is generating the electricity. Means for 50% of the work is generation, 50% of the work is with the consumption. With this process, these companies are going to save their costs by implementing this technology. Otherwise, if they take the electricity continuously, they will get the huge bills. So this is the one of the reason for implementing the microgrid concept. If you, as I told you before, if you take your college may get electricity bill every month 5 lakhs or 6 lakhs. If your college do some calculation and invest 1 year investment, 1 year electricity bill, that is around 60 lakhs, 12 into 5, 60 lakhs amount for implementing the solar system on their buildings, their electrical bill from the next year will be reduced, and the amount which they spend, they can recover within 5 to 10 years. Because the solar systems, they are giving 20 to 25 years guarantee and they are operating effectively. So instead of paying to the power market, they can design their own system, they can implement that system, and the system is under their control and it is beneficial for them. During the holidays time, the college will not work, so that they can sell that power to the electrical department and they can gain the money also. This is one of the advantage in this cost saving. By using these two concepts, everyone is preferring this microgrid concept. Next slide, please. Next slide. These are the technical benefits. If you want to go through, I will share the PPT. You can go through. There are a lot of benefits because of the microgrids. First one is, the main one is, because of usage of renewable energy sources, the pollution is very, very less, almost negligible, because we are using solar systems for generating electricity in the microgrids. we are using the windmills for producing electricity, which is also producing the zero emissions, and we are using the battery banks for storage the electricity during uncertain conditions. We will take the power from that one, and we are using rarely for the backup purpose diesel generator sets. It is used occasionally when there is an emergency. So in microgrid concept, we are using locally available resources. We are not bringing anything from far away. We are not doing any transport. We are not shifting anything. We are observing how much sunlight is available. With that means how much irradiation is coming from the sunlight. With that irradiance, how much electricity we can produce, and that electricity is sufficient for our need or not. After this analysis, we are going to design our microgrid. Similarly, if you see the windmills also, if you construct a tall pole around 20 meters height, and if you put a fan, means the generator over there or bottom of the connect through the gear system, you can produce the electricity. You can see small micro windmills on some of the areas I have seen on some hilly areas. They are producing electricity by using this method. So simply, microgrids means it is a grid formed within the small area. Say in your home also, you can tell a microgrid. If you have solar on your rooftop and the battery system in your home, it is simply a small microgrid. You are producing electricity by using the solar panels, and that can be supplied to your home needs. If you have excess, that can be stored into the battery bank. During the emergency conditions or uncertain situations, you are taking the power from the battery banks to the load. So you are operating your battery banks and the solar system based on your need, based on the situation. So you are operating these two within your home, means it is a small microgrid. But to form the microgrid, you need 3 to 4. Here, if you have possibility, you can construct a pole on top of your building, and you can put the windmill, so that you can get the 3 sources. One is windmill, one is solar, one is battery bank. And if you have more money, you can put the diesel generator in your home, so that you have 4 types of generation, 4 types of energy sources. By interconnecting all these 4, you can tell it as a microgrid, and that is within your home. So it is your home microgrid. If it is considered for a small community, it is a community microgrid. If it is considered formed for a college, it is college microgrid, or institutional microgrid. Like this we can call. Next slide, please. Disadvantage. This is the main concept for generally for doing research. We have to identify the problem. Generally, these problems are coming from the disadvantage of any concept. Not only microgrid. If you take any concept, that every concept have its own pros and cons. Based on them, we have to choose one problem, and we have to work out on that to get the solution. So here are the disadvantages. Voltage, frequency, and power quality should be at acceptable limits. If you observe this voltage, frequency, and power quality, generally, whatever the resources we are using for producing the electricity, those are in dynamic in nature. The sunlight, wind, all these are dynamic in nature. We cannot predict next minute how it will be. So during this time, how we can estimate a constant voltage or constant power or constant frequency? It is very difficult. So this is one of the main disadvantages in the renewable energy, renewable concepts. Before last year, when I attended a program in State Load Dispatch Center, Vijayawada, directly they are telling they are not connecting these solar systems to the existing power system, because when if some clouds are passing through, automatically within the seconds the power is going to reduce, which is coming from the solar panels. Within that time, if they cannot restore the system to they cannot balance the system, there is a problem of stability. When the stability problem occurs, it is a big issue. So that time The load dispatch center people explained their concept that they are not interconnecting the solar power systems to the existing system, because during midday it is very good, sunny time, sunny days, it is like a bell curve. But during the rainy season, suddenly clouds will pass through, so that energy will reduce. So they are facing these voltage frequency stability issues. Fluctuations are more. I will show you how a waveform. Next one is requires battery banks. When we have excess energy, we need to store that in the battery banks. So battery banks means it is a huge economic huge expenses. Simply, if you observe in your home, if you want to buy a battery for your inverter, it costs you around 8,000 to 12,000. But now think, for implementing in a plant or in a system, how many batteries you need, how much amount you need to invest for the battery banks. This is the one of the drawback. Batteries requires battery banks for electricity storage, which requires space and maintenance. Money, space, and maintenance. These are the three investments you need to put for the operating the battery banks. Resynchronization to utility grid. When you observe the microgrid, it is having different operating modes, as I explained you before: on grid mode and off grid mode. In the on grid mode, this microgrid needs to connect to the conventional grid, but it must be synchronized correctly. If it is not done correctly, there is a problem of stability. So resynchronization to the utility grid is very difficult. That is the third drawback. Issues, fourth one, issues such as standby charges as well as net metering are obstacles for microgrids. As you heard that before, from few years, we are hearing that there is a concept called net metering. Means this meter will measure how much power we are consuming and how much power we are supplying to the utility. Means when we have solar system on our rooftop, that will generate the electricity. If we have excess energy, that can be sold to the electrical system. So the meter, whatever we are naming as net meter, it will check how much we are taking, how much we are giving. The difference is going to bill. So net metering is obstacles for the microgrids. Microgrid protection is obstacle standing against the implementation of microgrids. Protection. See the protection point of view. If you observe the protection, we have to think in many factors. What type of protection does it require? What we need to implement? We have to follow. We have to follow our own system, or is there any regulations we need to follow? Like this, there is a lot of gap. That is one of the another disadvantage. And next one, ensure consistency. Interconnection standards need to be developed. Generally, as I told you, these microgrids concepts are not advanced in India. So we are in lack of regulations also. As per the standards we need to follow, but those standards are not yet completely designed. It is in the design stage only, even in the government also. So there are a lot of disadvantages. Each disadvantage we can convert it as a research concept, and we can do the research on. Now if you take the voltage in a microgrid concept, we are using the renewable energy sources. When we are using the renewable energy sources like solar and wind, these are uncertain in nature, completely dynamic every second. So when it is dynamic, the voltage will always fluctuate. How you will put this voltage as a constant? This is the one of the challenging area to choose as a research topic. For maintaining the constant voltage, we have to take the input from the solar system or the input from the wind system. We have to analyze how much is generated, and we have to check whether it is up to the standard or not. If it is not, how to boost up the value, or how to reduce the value, or how to remove the ripples and harmonics and all we need to do with the help of power electronics, converters, inverters, and bridges. So by using all these, we need to filter out the problems inside. Power electronics are the major concepts in this. So simply, I would like to tell you there is a huge scope for power electronics in the microgrid concept. I wanted to show you the very important slides we have, but the lack of time, I will scroll up fastly. Can you please go forward? There are advanced technologies. Please go. Please. This is the dynamic nature, how to understand. Please go, please. This is the dynamic waveforms. If you see the solar profile, the blue curve is the sunny day. When it is sunny, you can see it is like a bell curve with less disturbances. But if you see partially cloudy, it is completely changing. During cloudy days, you cannot imagine. Rainy day, it is completely zero. We don't know when it will happen like this. That's why this is the major drawback in the solar renewable energy systems. If you work out on this, it will be very grateful to you and it is very beneficial for you. So this dynamic nature you must understand, and you must design a power electronic system to maintain the stable operating voltage and frequencies. Next, please. These are the industry drivers to tell you. Continuous power supply. In the microgrid, we will get continuous power supply. There is no power interruption. Environmental objectives means the pollution is very less. Cyber attackers and hackers free operation, because it is having a chance of operating in standalone mode. So it is not connected to any third party, any other external sources. So nobody will do anything for this one. Low transmission losses, because of the usage of local available resources, the transmission losses are very less. Increased demand in remote areas and backup in military bases. See, when you see these microgrids, these are generally preferable in remote areas and in especially in high confidentiality areas, research laboratories, military bases, or ships, remote areas. These are the preferable areas for the microgrids. Next slide, please. This is the global market. This is very important slide for you to understand the market, to go for the to choose this microgrid concept or power electronics for the research. Global market size reached to 25.9 billion in 2021. See the prediction between 2022 to 27, 49.2 by 2027. It is CAGR of 11.2%. Means within 5 years, it is almost going to double the market. Not in 10 years or 20 years. Within 5 years, it is expected. Because of the COVID situations, it is very slow now, but it may reach before this date. 2027, 49.2 billion. Means these companies, IMARC, this is the research community. They will do research on the microgrids and they will estimate how this microgrid market is going to dominate in the world. So according to them, in 2020, they found 2021, they found $25.9 billion. But in the future coming 5 years, it is going $50 billion around. See, another one, global microgrid market, allied market. According to their research, in 2020, it is 15.88 billions. But if you see, by the end of 2030, it is $60 billion. Means, as per their research, we can assume that microgrids are going to dominate in upcoming days, in future days. But to operate the microgrid in efficient manner, we need power electronic converters, efficient power electronic converters. We must design good power electronic converters, inverters, converters, so put whatever the name. Because of the advancements in the electronics concept, these power electronics are contributing so much to the microgrids. So without any doubt, you can choose this power electronics concept as a major concept for your research. There are a lot of research gaps available in these power electronics areas, especially in microgrids. Every concept, every interlinking part is depends upon the power electronics concept. Next slide, please. Next slide. Next slide. These are already I explained, but I'll go through later. See, this is a small picture. It is going to explain power electronic converters in microgrids. See, AC bus we have and DC bus you have. In this AC bus, utility is connected on the top. Later, if you see, we have a electric vehicle. To connect the power to the electric vehicle, we must give DC power. So whatever the power coming on the AC bus, that must be converted to the DC voltage. So AC bus to AC voltage to DC voltage conversion is required. Here you need AC to DC converter. Later, in the third line, you have solar system. In the solar system, it will produce the DC power and it is going to connect to the AC bus. Means here you need DC to AC converter. After conversion, you must give the standard value that must be connected to the AC bus. And the last one, AC loads. So if you see any stage, there are lot of converters, inverters, and interlinking devices. Every one is a power electronic device. If you design a power electronic device nicely, the microgrid will operate smoothly. So the power electronics are playing key role in microgrid concept. Next slide, please. Please, next. We don't have time, so please, next. Next. Yeah, this is a research advancements technologies. When I'm doing PhD, I have attended several workshops and training programs. During that time, I have explored all these technologies. There is one company called Opal RT, OPAL-RT. This company is doing completely research on microgrids, and they have designed a test bench which is called PHIL test bench. HIL test bench. This test bench is used to analyze the microgrid. The standard institutions in India, IITs, they have adopted this technology and they are doing their research in the power system laboratories by using this Opal RT technology. So I have observed these three technologies during my research. Number one is Opal RT technology. Number two is Typhoon. Number three, Homer Pro. These are the three technologies available in the market for analyzing the microgrid, whether it is efficient microgrid or inefficient microgrid. So first one is called as test bench, and the second one, Typhoon, is called as test bed. The names are different based on the company design and all, but they both are doing the microgrid research. They are analyzing the microgrids. And the third one is software, Homer Pro. If you take the first one, next slide, please. Opal RT Technologies. See, this is the technology. They have designed a hardware kit. In this hardware kit, we can connect all the cables to that kit and we can check how much power is coming, how much power, what is the quality, voltage, frequency, power and all, and how much needs to supply. All these are done by using this test bench. This is developed by Opal RT company. If anybody is interested to learn about microgrids and their research through this HIL technologies, you can choose Opal RT or Typhoon. These are the two technologies that are available in the market. In many IITs, they have adopted these technologies and they are doing research by using these hardware kits. Because of the expensiveness, many companies or universities are not taking this one. Maybe in future the price will be less, so that everyone will take this one for doing their research. Next, please. Next, please. See, example I have given IIT Kanpur and Gandhinagar. They have already these concepts in their power system laboratories. And the second technology is Typhoon technology. HIL, hardware in loop. HIL means, H means hardware, I means in, L means loop. Hardware in loop microgrid test bed. It is also designed their own technology and they are using to analyze the microgrid. It is just like a mobile. If you see, there are a lot of companies available. They are producing the mobiles. We have Samsung, we have Nokia, we have Apple. But based on the public interest, they will go according to their own economical status. People who have more money, they will choose the best quality one, even it is high price. So here also, for analyzing the microgrid concept, there are two technologies available. One is Vopalarty technology, another one is Typhoon technology. Whichever is interest to you, you can contact them directly. They will give you their training session to you. Next, please. Next, please. Yeah, so please wait. Learn directly from Typhoon Hill. It is the academy which is offered by the Typhoon company. If you want to learn about microgrid and its research, analysis, and all, you can get the training from this academy directly after registration, and it is free of cost. There is no charge. You will get the certification from this Typhoon academy. They will give you after testing your knowledge and all. They will give you training initially, and they will conduct the exam. If you pass the exam, they will give you certification, and that is useful for your job also, for your research, for your R&Ds and all. Next, please. Yeah, this is Homer Pro. This is a software you can download for free, and it is available for 15 to 21 days. I think, yeah, 21 days. It is available for free. You can download and you can design your own microgrid, and you can check whether it is working nicely or not. Simply, you can select the area, whether it is Hyderabad or Vijayawada or Vizag. It will tell you the data from the NASA. It will take the data from NASA and it will put into your system, and it will check how it is going to work effectively or not. It is a software, not the hardware. First two are hardwares and the third one is software. Next, please. Say 21-day free trial. You can go through this one, Homer Pro. Typhoon, you have completely free. You can check it. I didn't find a free course for Opalati, but they are conducting in many colleges and universities workshops. They are giving the training how to work, how to do the programming and all. If you know the Python programming language or R programming language, it is very easy for doing this research in this microgrid concepts. I think it's over. Can you, yeah. Next, please. Yeah, that's it. Sorry if I take more time and if I'm talking continuously. Actually, if it is a two-way session, it is good. But I felt it is only one way. Yeah, I completed, madam. Please take care.
Thank you, sir. So thank you so much, sir. It's a very knowledgeable and a trendy session. It's a wonderful session, sir. I hope all the faculty, research scholars, and our PG students also hope they will get a good knowledge from this session, sir. It's a wonderful session. I hope. Yes, sir. It is a two-way session. Now our students or faculty, any faculty, they can ask questions, sir. So I request all the participants. Any queries you can ask.
Sir, good evening, sir. This is Rajesh, assistant professor from Triple Department.
Very good evening, sir. How are you, sir?
Yeah, fine, sir. Your session is very interesting and informative. Thank you, sir.
Thank you.
I have some queries, sir. The first thing is, as you said, the microgrid, we have whenever there is a load change, like when there is a sudden drop in the change or when there is a sudden increase in the change.
Generation.
Yeah, yes, sir. And also they mostly use renewable energy sources, right, sir?
Yes.
And renewable energy sources, as you said rightly, they imbibe or they inject some harmonics into the system, like when we use the inverter and all. So what type of protection requirements we have to do at the grid side, sir, as well as in the microgrid, sir?
Yes, sir. Actually, when you are using these renewable energy sources, no, there are a lot of disturbances.
Yes,
for controlling these disturbances,
Any queries, participant side? I request any participant, you can ask the question.
Yeah. Yes, sir. Good evening. I'm Tejava Jagadish.
Hi, sir.
Yeah. Hi. Yeah. As you mentioned that there are private players are playing vital role in generating distributing
Yes.
power. That was a really valid point I observed in your
Yes, sir.
Whereas, like as you were mentioning that thermal power stations are like generating 50% of like 50% of generation. What is your call on this? Does this thermal power station will be exist after 15 or 20 years, or how long we can depend on this coal related like thermal power stations or thermal power plant going to be in existing mode as per your knowledge and as per your area of research and all?
Thank you, sir. It's a nice question. Actually, these are the general questions we will get from out of the box, not from the book. Yeah, I have small experience with one of my friend who is working in power plant as an engineer. In thermal power station. One day, generally we are talking. When I ask him, he's telling in sad way, "Oh, my friend, don't know when these power plants are going to shut down."
Exactly.
Because it is a coal-based power plant, and day by day, the government is trying to close the coal-based power plants because of its pollution and of more operational cost and all.
To sustain the ESG, engineering social responsibility.
Yeah. So he's very sad at that time. I'm wondering why he's doing government job and he's suffering this much. But his analysis is exactly correct, because the government is taking steps for the renewables, not for the existing coal-based power plants. As soon as like you said, after 15 to 20 years, coal-based power plants, they are going to shut down.
Yeah.
But we cannot say exactly 15 to 20. It all depends upon the government policies. Now one government is running, next government don't know what they will focus. So, but if the people who are following this Paris Agreement, who are working towards the Paris Agreement, if they are really focusing on that, they will stop the pollution generated resources completely. The coal or oil or the gas, which are releasing the emissions into the atmosphere, greenhouse emissions, definitely they are going to stop those power generation. They are trying to implement these renewable energy sources concepts only. That's why many countries, many states, they are giving some policies, incentives. See, in Telangana state, I don't know, if you want to install 1 megawatt power plant, you may get 30 to 40% subsidy from the government. You need to invest only 60%. In that 60%, government will support you to get the loan of 50%. Means in your hand, you need to put only 10%. For example, if you want to install 5 kilowatts power plant for your home only, for operating the refrigerator, for operating the air conditioner, television, fans and all. If you want to install 5 kilowatt power plant, you can approach the government and you can tell that you want to implement 5 kilowatt on your rooftop. So they will check your area and they will give incentives. They will give subsidy of 30 to 40%. Means for example, if 5 kilowatts power plant costing 5 lakhs, they will give you 30% means 1.5 lakhs subsidy from the government. Remaining 3.5 lakhs, they will show you a bank which will give loan for your project around 2.5 to 3 lakhs. Means you need to invest only 50,000. So this is the way the governments are going to encourage to adopt the renewable energy technologies. They don't encourage you to to install the coal-based power plant. They don't encourage you.
Such things won't happen in future. As per my knowledge, probably
yes, sir.
like thermal power station going to be wind up by 15 or 25 years.
Yes, sir.
The main
I think
reason
this is I think in Kottagudem power plant, many units are shut down.
My wife is working there. My wife is
Oh,
working
you
there.
know me very well.
Yeah, that's the reason she was always asking me the same question. As I am into the private industry, I request her, I urge her to work on the soft way to enter into the private industry rather than working into the government industry where it will be going to be end up their lifespan. So
As
whereas
of my knowledge, in engineering
engineer-
college, every faculty or every student, they are thinking for assistant engineer government sector, assistant engineer, assistant executive engineer government sector. But other than this government, we have huge market in private sector.
that's the main question I wanted to point out. I request all the faculty members and on the call, you motivate your students towards not only state government electricity board recruitment, but also ask them to work on the private industry who are producing off of the generation of the they're high players nowadays. So they are paying huge salaries to the
Yes. With your support, if I get a chance in the future, I have one career counseling session. Means even in electrical section, electrical department, we have many software jobs in electrical sector. In electrical, not in the computers.
Yeah.
Electrical CAD you have, okay. MATLAB we have.
Yeah.
It's design engineer. If you see the design engineer, electrical design engineer, there is a designation called electrical design engineer. He will do the electrical concepts designing only. Okay.
Yeah.
And MATLAB, they will do the research. Okay. And many software jobs also available. But from our basics, we are looking for the government job. And government is stopped notifications. I think within 10 years, they released only three notifications. Within the span of 10 years, they released only 3 notifications.
Yeah.
So it is very difficult. And the concept here is power plants which are operating with fossil fuels, they are going to stop as soon as possible.
Yeah.
Especially these thermal power plants.
Of the box, and we need to on this.
Yes, sir. Thanks for that question.
Thank you so much for having you. You have shared lots of insightful. Probably your PPTs may help VJIT students or other faculty members who are there in the call. Better ask them to share so that it will be useful.
Yes, sir.
Yeah,
Sure,
I
sir.
have
Sure,
shared
sure.
already.
Sure, sir. We'll share.
No objection for me.
Thanks for the opportunity, VJIT team.
Sorry, madam, your voice breaking.
Sir, one more question, sir. Yes, sir. Madam, your voice is breaking, ma'am.
Your voice not clear, ma'am.
Madam, your voice is not clear, ma'am.
Please tell me, madam. Yeah, okay. Proceed.
Yes, sir. I was really thankful for the PPTs, whatever you have shown. Seriously, there is lot of statistics, so we can go through these PPTs. Because
Yes, madam.
as always said, concepts will be there, but statistics we usually not give to the students. But this information is really informative for us if PPTs helps us. And one more question, sir, from my side.
Okay, ma'am.
We are talking about the microgrids and the converters, right? Where
Yes,
power electronics is not in microgrids.
Power electronics are the key players in microgrids, ma'am.
Yes, sir. Yes, sir. And I can say because of these converters, there will be lot of harmonics which is generated.
Yes. It is a huge cost expensive system. That's why not implementing quickly.
Okay. Yes, sir. That is what I am asking. How this research in terms of reducing harmonics helps us, sir?
It's completely technical descriptions, madam. Actually, in this session, if you go to technical like a curve, waveform, lagging, leading, like that, it is not useful as of my information. Okay. It is possible only in the classroom sessions and only the face-to-face. Now it is a 1 hour session only. To create the interest towards the topic, we need to show some statistics and we need to show some gaps so that the participants get motivated to choose that topic. That's why I have prepared like this. Otherwise, I may put some waveforms or some timings.
Yes, sir, definitely, I understand. So, very nice PPTs and very good statistics from your side, sir. Well, thank you very much, sir.
Thank you, ma'am.
Okay, sir. Thank you. Ravinder, sir, you want to ask any questions, sir? Ravinder, sir.
Sir, out of, I think so.
Sir raised a hand, sir. So that's why I'm asking.
Yeah, he raised the hand.
Yes, sir.
Yeah, very good going, sir. How are you? Very good, sir. Okay. Okay. Is it dry land or agricultural land? Which area, sir? Nalgonda. Okay. Okay. They don't allow you, sir. It is not like simply tapping our home wire to the line. Yeah. No, sir. Tell him to go for government subsidy so that they will explain all the procedures to get into. If he has some money and he want to put investment in that, he cannot get such things. They need to go as per the system. This is electricity production, no? So they need to contact the electrical people who are in the regulatory board. They will guide him how to do what to do. Otherwise, they don't allow him. Okay, that's floating is different, sir. Floating is different and land is different. Please tell him to go the place, I think in Anantapur or Raichur, somewhere there is a big power plant, solar power plant. It's very big in south. If he go there, he can observe what is the practical difficulties. What are the practical difficulties, like mounting and all civil structures for placing the solar panels and all. And after placing that one, every 3 months, they need to cut the plants, because we know. Yeah, and how much it is expenses. Next, cleaning of the panels. Next, cabling. Next, control panels. Next, construction of shed and all. Labor investment. They financial statistics they will explain first. Later, they will check whether he is able to come inside or not. Because if he have only 20 acres land, what about the investment? Tell him to give directly to the government on lease, or any private company. They will take this 20 acres land or partnership in their farm. He can be a partner and he can learn, so that after 5 to 10 years he can adopt that for him. Yes. Yeah. Did he have any experience, sir? No, sir. Technically, if you have some experience, tell him to work for 3 years at least, solar. As I told you in the presentation, there is a software, Homer Pro is available. Tell him to design his own microgrid in that software and ask him to check whether it is reliable or not. Yes. Yeah, there are a lot of difficulties. My friends who are staying with me, they tried for implementing solar power plant in the India, and finally they raised their hands because of the government policies and issues. Yeah. Yes, sir. Yes.
Sir, a small question. With this government policies and this Indian system, can we have this renewables? As rightly said by Mr. Jagdish, he told that within 15 to 20 years we are going to we are not going to have this thermal power stations. Then where is India standing after this 20 years? And what is that we are going to show to our kids or our children with these renewable energy sources? Because of these policies, all these rules and regulations and all in India, what is our situation?
Yeah, if you observe these recent days, India securing better positions in the renewable energy sector. They have implemented, they have installed huge amount of electrical generation, and it is under operation. And as I told you, India is in lead position, I think second or third in the renewable energy sector. They are implementing policies very nicely.